So welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is what is autonomous. The word autonomous may have been used by different fields in a different sense or different meaning. So because of that reason, we talk this autonomous in the sense of navigation. So let's move on to the main content of this presentation. Since we have seen driverless vehicles on our streets, we can categorize that the birthplace for autonomous navigation is the automotive industry. However, before these autonomous navigation systems, we had autopilot systems in the all transport systems. I think these autopilot systems may have made the pathway towards this autonomous navigation type innovations. So when you talk about these autopilot systems, I think both all land, air and sea transportation systems being equipped with such systems, but there are some variations. For example, in land transport systems, driving vehicles, initial autopilot systems were limited to speed control. And then when you talk about the air and sea transport systems, they were also not just the speed control, but also steering capabilities were there. I think the main reason is they had additional dimensions compared to the land transport system. In the land transport system, you should go through a given road structure, so your maneuverability is somewhat limited. So you need quite a lot of decision-making power and the informations to make those decisions. Because of that, I think initially the land transportation systems were limited to speed control. But air and sea transport systems had that additional dimension. Because of that, they were capable of doing not just the speed control, but also steering control decisions. So let's talk about the autopilot systems in shipping. These autopilot systems can be categorized as integrated control systems developed to control propeller, rudder and thruster systems in ocean-going vessel. Generally, these systems are supported by limited feedback loops of information. So this information can be vessel position, speed, heading, course, and rudder, propeller, thruster informations to do their operations. So some of the features can be categorized as this heading control, course control, speed control, path following, waypoint navigation, and dynamic positioning. So let's go through each one of these features and get some sort of a rough idea about what these features are capable of. So let's discuss these features in ship autopilot systems. I have also made a video on the navigation strategies for underactuated systems. So if you haven't seen that video, please go through with that because you might get a good idea about these features when you are seeing that video on with respect to the navigation challenges these vessels can face. However, and I would place this link to that video also in the description of this video. So let's move on to the main features of these autopilot systems in ocean-going vessels. So the first one is heading control. So when these vessels are trying to keep the constant heading under various weather conditions, then we categorize as a heading control situation. So you can see the heading vector in this vessel, which is denoted by H, is pointing towards the true north. Even though this heading vector is pointing towards the true north, its course speed vector is slightly into starboard side. Because of that reason, the vessel is drifting towards the starboard side. So the next is course control. So in this situation, the vessel is trying to keep the constant course angle under these weather conditions. So you can see the course speed vector is pointing towards the true north in this situation, and the heading vector, which is denoted by H, is pointing towards the port side in this situation. So because of that reason, even though the vessel is heading into one direction, it is drifting towards the true north in this figure. So the next feature is speed control. Here I am trying to say that if this vessel is keeping both heading and the course speed vectors in the same direction, it would be easier for the vessel to control its speed. But that is not a must requirement. These course and course speed and the heading vectors can have two separate directions. And then so the next feature is path following. In this situation, these ocean going vessels are assigned with a specific path with a reasonable width under various weather conditions. So the main objective of the autopilot system is to keep this vessel positioned within that path while it's executing the required speed. In some rough weather conditions, these vessels can drift away from the path. Then the autopilot system may jump into a manual mode where the human pilot should come and start controlling the vessel. So the next feature is waypoint navigation. Often in moderate and rough weather conditions, vessels may not be able to follow path following type of features. So in that case, this waypoint navigation can be an suitable approach. So in waypoint navigation, what could happen when you have a specific ship route to follow? The ship route can be segmented with respect to different waypoints. So then these waypoints being assigned to the vessel. So the vessel objective is to keep the course speed vector towards the next waypoint. So when it's come to the vicinity of a waypoint within some distance, it can classify it as the situation where it achieved that waypoint. So then the next step would be in these vessels to change its course speed vector towards the next waypoint. So in that type of iterative way, these vessels can navigate in these moderate and rough weather conditions. So the final feature is the dynamic positioning. This can be, you can consider this as a more simplified waypoint navigation. So the whole objective is to keep this vessel near or the vicinity of a given waypoint. So if these vessels have additional thruster systems utilizing the existing propulsion systems, these vessels would be able to stay within the vicinity of these waypoints, even though these vessels can drift due to some weather conditions, but it may have enough power to keep these vessel position within a given range of these waypoints. So let's try to answer the main question in this presentation, which is what is autonomous in navigation? If a navigation system satisfies the requirement of an intelligent agent, I think then such system can be classified as an autonomous navigation system. So let's try to see what are those requirements. So these requirements generally coming from the field of reinforcement learning also. I think there's the contribution from the reinforcement learning is somewhat higher. So the intelligent agent requirement would be, it should have this following five requirements, which is autonomy, social ability, Tec-Interaction, reactivity, and proactiveness. So let's try to go through each one of these requirements and see what that mean in the sense of autonomous navigation. So let's go through this intelligent agent requirement so that we can understand the autonomous navigation in the shipping industry. So the first requirement is the autonomy. So that means without any direct or indirect influence from humans, the agent should operate with its own decisions and actions. These can be classified as internal states while following the regulatory framework. So if you are talking about autonomous ships, these vessels should make own decisions without human interference and then also follow the regulatory framework. For example, in a collision avoidance situations, COLREG type rules and regulations should be implemented. So the second requirement is social ability. That means these agents should have an appropriate communication language to interact with other agents and the relevant parties, including humans. So in the situation of an autonomous navigation, these vessels should be able to communicate with other autonomous vessels as well as the manned vessels in this mixed type of environmental conditions where the autonomous vessels as well as human vessels or the manned vessels are interacting. So the next requirement is a Tec-Interaction. So this agent should interact with the relevant technologies as well as the decision support systems, not just to understand but also process the information given by these systems to make their decisions. For example, in ship navigation, the collision avoidance can be such type of situation where decision support systems of collision avoidance can be utilized by this agent. I would believe this agent would not have capabilities to make decisions on every situations in ship navigation, In such situations, this agent may need additional decision support layers on top of their behavior to make appropriate decisions in a ship navigation condition. So the next requirement is reactivity, because the environment in these navigation systems can change with respect to the time. So there are time varying environmental changes and challenges. So the agent should interact with such environment and respond to such type of situations. So if you are thinking about a ship navigation situation, if you have rough weather conditions, these vessels may be able to navigate through rough weather situations, but in such situations it may need additional decision support systems that we have discussed in the previous slide. For example, helping these vessels to minimize their vessel motions on these under this 6 degree of freedom, so that way these vessels can navigate somewhat in a safer way under rough weather conditions by utilizing some of the available decision support systems. So the next requirement is proactiveness. So if in a respective environment, these agents should take appropriate initiatives to satisfy the goal-oriented behavior. So if this is in a ship navigation situation, the vessels may assign to a specific waypoints to be navigated within a given time frame. So these vessels should satisfy that requirement, not just the navigation side. If you have additional requirements like minimizing the unwanted motions and so on, so that should also satisfied by such type of systems. So those are the intelligent agent requirement that should also be adapted towards the shipping industrial requirements to be these autonomous vessels in the future. So that's pretty much the end of my presentation, and hopefully you have enjoyed that. So if you are still interested, please stick around. Thank you.